Thank you very much. Bonjour. So I'm happy to have a good opportunity to talk here. So my talk is I think more casual. So you can relax during my talk, I think. Okay. For the beginning, let me introduce my childhood. Childhood. So when I was an elementary school student, I read very interesting book. So that is about the name is Introduction to Magic and Juggles. And so I found a lot of magic inside the book. And at that time, I thought I wanted to be a magician. Unfortunately, I'm a professor now, not a magician. But I think after several years, one day, I also read I also found very interesting word by Sir Arthur C. Clarke. So he said, any sufficiently advanced technology is indistinguishable from magic. I think that's for the realization of this technology like magic. Our current technology is like magic. The sense of embodiment is, I also think, the sense of embodiment is one of the most important elements. I also think. And this is my motivation to research on augmented human. Can you hear me? I think, what are the challenges in creating interface for enhancing the human sensation and expressions? And in order to illustrate the definition of augmented human, please see this figure. I think in real world, you can touch something, or you can touch and hold something with your hand. And now we have some research on teleexistence or telepresence. That is technology allows you to touch, remote touch or hold, remote object by using some haptic or bilateral control. And I also think augmented human allows you to touch remote object as if your hands are extended like this. This is one example of augmented human, a technical achievement of augmented human. Actually, this research is collaborating with Professor Michael Harrer from in Austria. And we also have demonstration of this work here in 2010, and it was chosen as Grand Prix to jury in Laval virtual. Let me show you video of this.
Nowadays our living rooms are filled with electronic devices, and each one comes with its own remote control. Finding the right remote and remembering the different layouts can be a challenge. Crystal uses a camera to capture the entire living room, including devices such as TV, speakers, lights, vacuum cleaner, or digital picture frame. The captured video is displayed on a multi-touch coffee table. Users can directly interact with the devices in the room. The video image itself is the interface, and it offers instant feedback. Lights can be dimmed with a simple sliding gesture. Today, movies are often stored on media servers. By tapping on the image of the DVD collection, movies stored on the media server can be accessed. Covers can be moved around the whole screen. Users can also read more about the film and watch a preview of the movie directly on the table. Movies can be watched by simply dragging a cover onto the video image of the TV. An additional interface facilitates further control of the movie. Speaker volume can be adjusted with a simple sliding gesture. By tapping on the video image of the photo album cabinet, the digital photo collection is opened. Similar to movie browsing, users can view photos directly on the coffee table or enlarge them on the TV. Dragging a photo onto the digital picture frame uploads the photo for display. Crystal also serves as an interface for the cleaning robot. The robot cleans up everything in a path drawn by the user.
I think this is an example of augmented human. And so, in order to design this kind of system, I believe, we need to care of three elements. That is our Earth. That is physics. In order to design real world, of course, we need to learn mechanics of materials. And so in order to design information world, a digital world, information technology and mathematics is very important. And then, in order to enhance our human itself, basic knowledge of our human is, I think, sensing and perception. And so all of our work are based on these three elements. Okay, so let me introduce some achievement of enhancement of vision. So in 1999, we have developed optical camouflage system, and it was also chosen. That is projector-based system. So here is projector, and background image was taken by this camera and projected onto his clothes. And his cloak, my cloak, is made of very special material. That is retroreflector material. And thanks to these three elements, you can observe myself as if my body become transparent. And that is a sort of technology to make you acquire X-ray vision. That is also a sort of a kind of achievement, technical achievement of augmented human technology. And now we have a head-mounted type projector like this. And let me show you a movie of this technology.
透明になれる研究をしているとの噂を聞きつけやってきたのは
Sorry, this narration is in
透
Japanese.
明になれる歴史的発明を成し遂げたすごい研
So
究者がい
they
るとい
found
う
very interesting professor who invented optical camouflage
南
technology.
雅彦教授海外からも注目される透明技術の第一人者とのこと
ですね、こんな風に透明になれるかどうかを我々調べているんですけども、どうなんですか先生。
我々が使っているその技術
So they are looking for technology of invisible cloak.
可能ではないか。
And so
じゃあこんなこともできるってことですか？パッみたいな。
かもできるかもしれない。
あーすごい。でも実際どんな技術を使って透明になるんですか？
それは今実は私が着ている
So
このコート
this cloak
これはあれですね、
is a secret.
私服ではなかったんですね。
いや普段こういう
that is not my private
はいはいはい
private
はい。
garment.
これで？先生でもまだ消えてないですよね。
全然見えますけど。
まあこれを使ってさらにもう一工夫ですね。
百聞は一見にしかず 早速透明になっていただくことに。
And here is
本当にそんなことできるの
here's
か。
projector.
すごいすごい
Now she is looking for me.
透明だよだって後ろのバッグ見て
And so you can see as if
バッグ見て
so
ポスターの
my body is transparent.
ポスターの近く。
え
山根。
And this is
山根さん
a real-time system. You can also see his image through my body.
先生中に山根さんがいる
なんで透けてんの？
なんで
この、コートと、あとそちらの装置に秘密が
Actually, so this work was chosen by Coolest Inventions in Time magazine in 2003. And now we are continuing this research in order to apply this technique to a car. Of course, that is not for cloaking a car. So we applied our technique to interior inside of the car. So it allows you to observe so outside the image as if so car wall or car meter become transparent. And so let me show you a video. This is a collaboration with Toyota.
360度クリアビューの透明プリウスを作りたい。その思いが現実となる日がついに来た。
Toyota tried to make
稲見教授をはじめ
transparent
携わった
Prius.
学生たちやスタッフが見守る中、運転席に乗り込むのは免許取得から一度も運転をしていないというペーパードライバーの高橋
Actually,
さ
so
ん。
she's a novice driver. He's beginner driver.
車庫入れは苦手という
So
か
he just
したことない
get
ので
license 1 year ago, and she has no chance to
彼女に限らず
take
車
car
庫入れが苦手と悩むドライバーは多い。
after she
まずは普通に運転してもらうことに。
a driver license.
快適ですね
はいだいぶ運転しやすそうですね
はい
ここで稲見教
And
授から
this
声
is
が
normal mode.
じゃあ始めましょうか
はい
このスイッチを押すこと
And
で
now she
透明
turned
プリウスに変わるという。
she turned on
あーすごい
あ見えますか
optical camouflage.
はいすごいですね
あよかったです
外からは一見
From
変わったとこ
outside,
ろは見
it
えない。
looks normal Prius, normal Toyota car.
後部が丸々透明になって
So thanks to optical camouflage, the driver can see as if this backlight turns transparent.
もともとこうだったものが
This is normal,
このように
but
360度とはいかなかった
now
が
she is looking
後ろが
for
丸々クリアビューになっ
background
て
image, backside image.
透明になったプリウスのドライバーに彼女を選んだわけ。稲見教授のねあっさり失敗。普通の状態で車
And
庫
so
入
with
れ
the
に挑戦。
optical camouflage system, it's very hard to
あっ
hard
さり失敗。
to correct position.
さあ
But
こ
now
こから
she's
が本番
trying to
実
use
験スタート。
she's trying to use optical camouflage
す
system,
ごいはっきり見え
so
ます
she can easy to
わーすごい
see
お
so this kind of
ー
obstacles.
コーンとの距離わずか数センチ。危ないとその時なんとかクリア。そして
And here's camera.
はい OK です、
はい
ありがとうございます
Now she can put this car to exact perfect position. I think this is also a sort kind of technology of augmented human. And this is another example of visual augmentation that is for colorblind people. So as you know, 5% of male has a problem of colorblind. And so one of a student at Keio University has developed iPhone and Android application for colorblind people. So you can find this application on Apple Store or Android Market. That name is chromatic glass. And
色弱者の人が見えている画像です。
So this is simulated image of colorblind people. So it's very hard to find a difference between red and green like this.
赤の部分が本当目立ってないですもんね。
じゃあこうするとどうでしょうか。
こうするとはっきりとわかりますね。
And so this application can change brightness. So based on color difference of color, and colorblind people can find so red area or green area. So
数理工学、情報セキュリティ、色彩学などを得意分野とし。
And so what's the interesting point is so this one. Do you know who he is? He's Vincent van Gogh. And so actually it is said. So he also had a color blind. And he tried to simulate so what Goho see. So his painting. So this is original paint of and self-portrait of his face. And after adding the color blind simulator, so this is simulated image, but Goh saw like this. You can see difference of these. I think it looks much so normal. This is green color is vivid. This is much normal. This is also famous picture paint. And this is simulated image. This is original. This is simulated. This is also very famous. But this is original image and simulated image. And so we found I think Goh usually use so green color for the shadow, but from Goho's view aspect, it is like just shadow, not green. I think so. I suspect so color blind so help to paint so artistic image to Goho. This is very interesting research result. And let me move on to the next research. That name is stop motion goggle. So this is a sort of glasses. So expand your visual perception. Expands your visual perception. So most effective application with stop motion goggle is to observe moving objects, so which cannot be perceived clearly by naked eyes. So stop motion goggle consists of two ferroelectric liquid crystal devices. These simple wearable devices expand your visual perception. So this is FLCD. This is a kind of liquid LCD shutter glass for 3D vision, but it can be modulated very quick. And when you put these eyeglasses, so this is a naked eye image, and we add, and this is with SMG, so you can see surface texture of this wall very clearly, like this. And this is a fan. And so thanks to SMG stop motion goggle, you can see this moving fan very clearly. This effect is similar to stroboscope. However, so you should use stroboscope in a dark room. But so SMG allows you to use this system outdoor environment under the sun. And my student found very interesting application of SMG. of course, it's very hard to stop same characters here. But so with SMG and so hard training with SMG, so he succeeded to find 777. The last one is difficult. Now 7 is coming and stopped. Now he's happy. Of course, any electronic devices refused, prohibited in casino. So if you find me with special glasses at casino, please do not say this kind of research. Anyway, so what's the interesting point is, our eye perception, visual perception, is slower than our hand movement, not so accurate. Of course, we can see very clear image if the object is static. However, when we move like this, it's very hard to observe. And so this stop motion goggle allows you to observe clear image. And he can learn, he started to learn timing of slot machine. So this is enhancing feedback loop of a user. That is a very important point. So not observing image is not enough. So it can help your task. That is a very important point. And that is also contribution of augmented human. And we have also developed haptic augmentation by using small robot manipulator. So it is named Smart Tools. It consists of some sensors and force feedback devices like haptic display and closed loop based on this sensor. This is the initial application of smart tool. So we made virtual jig by using this technology. So without this machine's help, it's very hard to follow and draw straight line. So if the object is moving, however, if the user use smart tools in this system, so he can draw straight line even if the object is moving. And the user feel some transparent jig appears, and he just follows that jig. You can also draw circle by using this tool. This is without this tool. This is with this tool. With this method, he can also draw a circle like this. And then, we have developed a very interesting system which allows you to touch chemical boundary. Such as boundary between oil and water. Okay. So, actually this is smart tool, a sort of haptic display. And now, he's touching between oil and water. Actually, we put a water sensor at the edge of this stylus. And we also attach small haptic display here, and when the sensor detect water layer, the system is adding upper force to the user. But this user think as if this water layer become lava or something zero. Now he wants to stick water layer, but he can't. But with that smart tool, he can easily to stick water layer like this. This is another application of smart tool. So we add color sensor, optical fiber-based color sensor onto a scalpel, and we also put haptic device like this. And actually, here is a boiled egg. Now he's cutting a boiled egg freely. And thanks to smart tool, so he can cut only egg white. So actually, this color sensor can detect egg yolk, yellow part, and the user feel as if egg yolk become harder, like a nut or rubber, and he just cut with his hand, but he can precisely cut only egg white. I think this possible application of haptic smart tool is medical area. So this system can protect a very important nerve or blood vessel. And this is not for augmented human, but based on smart tool technology, we have also developed a sort of haptic AR system, which allows you to touch through this touch panel like this. So this system is for iPhone, and by using stylus, you can touch only this surface. But we just combine this is shrinking physical stylus and virtual stylus, and this also has a sort of haptic feedback. And thanks to three-dimensional gyro sensor, it can detect orientation of the stylus. And this system consists of a motor for force feedback and a linear encoder to measure how the stylus is shrinked. Now you can see virtual stylus here. Now he's touching this polygon. And you can play a billiard game with haptic feedback through touch panel. this application is for normal touch panel. So you can also draw three-dimensional line by using impact system. And now he's feeling a heartbeat of human, and this is heartbeat of a horse. And in Japan, so we have shoji, that is paper wall, and kids you like to stick, so shoji paper, and this is a game for stick shoji. Also in future you can use it for game applications like Nintendo DS. So we are also trying to enhance our vestibular sensation. So that is balance sensation of our inner ear, placed our inner ear, and collaborate with Professor Taro Maeda at Osaka University.
Or GVS is an electrical stimulation technique to the vestibular with an electrode on the mastoid behind each ear. The weak current through the electrode provides the user the sense of lateral virtual acceleration toward the anode. The vestibular system is sensitive to GVS intensity changes and responds by altering the magnitude of the response accordingly. This stimulation is known as the functional test of the vestibular. When GVS is delivered to the mastoid through electrodes while walking, subjects respond by deviating towards the anode. Using this device, we can control a player's walking path remotely with radio waves.
Now she's controlled by Professor Maeda.
We can apply this technique to an automatic collision avoidance system for pedestrians. Moreover, this system is particularly useful for performing interpersonal kinematical sense sharing for amusement. You and I can move each other. GVS can induce vection without an expensive motion platform. You can perceive a virtual sense of acceleration when you are playing a racing game, or watching a movie that moves you. Through high-frequency rhythmical stimulation of more than 1 to 2 hertz, you will feel your sight and body start to shake, synchronized with the rhythm. This experience is a novel sensation in human sensory display.
So this is also interesting application. But anyway, so stimulating galvanic vestibular, stimulating vestibular sensation has a lot of application. So it can thanks to GVS, so the user can be controlled by system, and so we can easily to control trajectory of pedestrians, and it is like it can work as if you acquire a sort of sixth senses. But actually, so long-term effect of vestibular sensation is nobody knows such kind of long-term effect. And so instead of galvanic vestibular stimulation, so this is actually not my work. So this is done by Professor Sumutachi and Professor Kota Minamizawa, and so they have developed. They are my colleague, and they have developed haptic-based human navigation system. So it is named HapMap.
Haptic navigation system, a way to navigate through complicated roads as if walking a straight road. There are many kinds of navigation systems available. However, by using them, one tends to concentrate on the navigation system itself. So, when they visit an unfamiliar place, people view a map or navigation system. Their eyes are engrossed on that. They may lose a chance to discover their surroundings for something new, beautiful, and exciting.
Please turn right in 100 meters.
直行100米，右转。
Por favor, vire à direita em 100 metros.
Please turn in 100 meters.
Do I have to listen to the voice of the navigation system? Of course not. Therefore, we propose a method of an incognizant haptic navigation system, which replicates the pressure distribution of sliding a hand along a handrail.
The system itself is very
Imagine
simple.
that when you enter your destination through your mobile phone, an invisible virtual handrail is stretched out of your destination. You cannot see, but you can feel it through the HapMap system. After that, all you have to do is to follow the handrail by haptic sensation.
HapMap offers 3 points of difference from previous studies in HapMap. Is able to present not only right and left turn navigation cues, but also subtle navigation cues for navigating a winding road and or path. Conventional navigation systems tell users to go straight even when the road or path curves in one direction or another. HapMap solves this problem and allows users to navigate a path every step of the way. This is particularly useful for the visually impaired who need these subtle cues to successfully navigate a winding path. In this sense,
So now we are trying to connect this device to our smartphone. Okay. So we also have developed a sort of this is a sort of haptic enhanced system, but that is not for your hand, but for your mouse. So we have developed chewing jockey system. So there are 3 key components. So photoreflector and microphone and bone conductive speaker, and which allows you to feel change of texture when you are eating a food.
こちらは慶応大学の稲見先生です。お願いします。
そう。
またちょっとシンプルな。
そうですね。
はい。
装置の名前は
チューイングジョッキーと。So thanks to this system provides audio and vibration signal, but so thanks to cross-modal effect, integration of sound and tactile sensation, this system allows he to feel. So now he's. Can you hear sound? At first, so we use low pass filter to modify this potato biting sound of potato chips, and now he's feeling as if potato chips is not so crispy, and when we add now
なんか後半重い感じになってきたな。なんだ？途中からちょっとしけったような感じになったり、またポリポリ戻ったりっていうようなことが今あった。なんか
This is
いい音。
this is we are using high pass filter. Here is low pass filter. And he felt so food texture was changed during his biting.
今度は食感をファッといろいろ変えて。
やりたい。
顎のセンサーで、口の動きと、であとはこちらの噛んでる時の音をしてでそれに合わせてエフェクトをかけた音を骨伝導で返して。
ここで拾って機械の中で何らかの音に変換してまた
送り返して。
じゃあいきますよ。
はい。Now he's
びっくりした。
すごいね。
biting.
力強いな。
Now he's feeling as if
どう感じるんですか？
this snack is really crispy.
すごく硬いもののように思います。
ああ、いつもよりも。
But he feels this is very
だ
hard.
からすごく噛まなきゃっていう気持ちになりますね。まず。でこれ変えることもできるんですか？はい。へにゃへにゃに。
ふにゃ。
どうなんだろ
かわいい感じになります。
う。かわいい。僕かわいいね。
見たことあるな。
So if we add this kind of different sound, so he feels this is much tender.
どうなるんですかこれ？
不思議ですよ。さっきは硬くて今は柔らかいようには思いますね。
で実際にその我々がその
And so now, so we are trying to use this technique to artificial teeth. So artificial teeth has large problem, of course. So with thanks to artificial teeth, so elder people can eat so hard food, but they usually complain. So it reduces a taste of food. The reason, or one reason, is so this kind of artificial teeth suppress perception of food texture. So this artificial teeth does not cover your tongue. Your tongue can must feel taste of food. However, so we understand. So food texture is very important element. So in future, if we embed this kind of chewing jockey system inside this artificial teeth, I believe elder people can still enjoy texture of food. That is like audio assistance system. So on this Laval virtual, so we also please come to our booth. So we also have a sort of sync enhancement system. That name is silent humming. So in Japan, so we usually need to take very busy train, so in order to go to our office. And that is so crowded, and so it does not chance to sing a song, of course, inside the train. But this system allows you to sing a song without any voice. So this system consists of two elements. That is your throat position sensor module. So please touch your throat. So when you sing higher voice, upper voice, so you can this throat position is moving upper side, and when you say lower voice, so this is moving to lower, and so this sensor can detect your silent breath sound, your breath sound. Sort of enhancement of your seeing experience, I believe. Okay. And so finally, let me introduce why I try to develop this kind of research. Of course, one reason is my childhood dream. That was I wanted to be a magician. The second reason is, I think, actually, this is very important secret of Japanese current research. So, in Japan, technology and pop culture has very tight connection. So, when I was a child, when I was an elementary school student, I loved to read a comic which name is Doraemon. So, it is a popular Japanese comic, not only in Japan, but also in Asian area. So this comic is about an earless robotic cat named Doraemon, who travels back in time in the 22nd century to aid a schoolboy. I think he provided a lot of interesting gadgets, and I think I still found a lot of hint of research inside this comic. And this is another example of pop culture. So how my research can be affected by pop culture. So do you know this movie, which name is Ghost in the Shell? So it was sort of a very important textbook of touch laboratory at the University of Tokyo. I must read. So when I joined to the laboratory, in order to organize discussion with assistant professors. And so in that comic, in that movie, I found very interesting scene. できないわな。
光学迷彩はアニメ広角機動隊の中に登場する仮想のテクノロジー。南さんがインスパイアされたのがこちらの。
In that movie, now she's putting some optical camouflage system.
プロデューサーの市川さんは
Actually, I was strongly inspired by a movie, and then and one day I took time to develop optical camouflage system based on projecting technology. I got this idea from this comic, and also found interesting phenomena. So, in 2004, based on research, some Japanese, so I found my research inside Japanese comic. that is named Chameleon Suit. That is also a famous comic in Japan. And so here is method to make chameleon suit. Here is my web page. So this is almost same. So they learned our technique from our website. And the last scene of this comic was not so happy. So optical camouflage was damaged, and inventor of optical camouflage abandoned to research optical camouflage system. But I'm still continuing that research. And of course, so let me remind you, so my definition of augmented human. So this is also inspired by Japanese comic One Piece. So that is Gom no pistol, like this. So I think this is a good example of how pop culture affects Japanese modern research. And when I was a high school student, so every day I visited Akihabara to find very interesting electronic gadget. And now it is known by a capital of not only technology or electricity, but also pop culture. So many visitors come to Akihabara to find interesting top-end pop culture in Japan. That is also good example how technology and pop culture can be connected in Japan. Okay. So finally, based on research, I started to think this is also my slogan of my current research. I think the best way to gain a magical power is to polish technologies. I think in order to polish our current technology in the near future, so it helps as if we gain augment human power or like X-Man. Okay, finally, so let me introduce you two conferences. The second one is much important. We have started new conference on augmented human since 2011, and in this year it held at Megève in France, and the next year it will be held in Stuttgart, Germany on March. This is March 7 to 8. And this is just advertisement. Actually, so I'm chairing emerging technologies at SIGGRAPH Asia. And please submit. And it starts to, it opens submission page. Please submit your best work to this. It will be held in Singapore. And so you can also find related works or other works about my research on my website or our YouTube channel. Please find many videos there. Thank you very much. Merci beaucoup.